Hello everyone and welcome to this GitHub Actions introductory. My name is Daniel. I am a hybrid cloud solution architect with more than 18 years of experience designing and implementing solutions involving public and private cloud technologies from Microsoft and other manufacturers. Something else about me, I have some hobbies in my free time. I like to travel locations on a motorcycle, blogging, team sports, extreme adventure, community involvement and more. I currently work as a customer engineer at Microsoft in the area of apps innovations for Latin America. In order to be able to concentrate on the presentation and not on my I will deactivate my camera and proceed with the content of this introductory material of GitHub Actions. I hope you enjoy it and find it useful. If you hear some noise or interference, I apologize, but as you know, we are still with certain restrictions of the pandemic and I have my house full.
On the topic of GitHub Actions, you will find out what GitHub Actions are as a product as we provide you with an introduction. Next, you will become familiar with the different components of a GitHub action. We will cover repository secrets. Then, find out what self-hosted runners are. You will be given a glance at the GitHub Actions API. Then, we will cover how you can post your action to the GitHub Marketplace.
To complement a little what has been seen and in the form of a summary, let us see. GitHub Actions is a continuous integration and continuous delivery CI and CD platform that allows you to automate your build, test, and deployment pipeline. You can create workflows that build and test every pull request to your repository, or deploy merged pull requests to production. GitHub Actions goes beyond just DevOps and lets you run workflows when other events happen in your repository. For example, you can run a workflow to automatically add the appropriate labels whenever someone creates a new issue in your repository. GitHub provides Linux, Windows, and macOS virtual machines to run your workflows, or you can host your own self-hosted runners in your own data center or cloud infrastructure. Advantages of GitHub Actions are: 1. Fully integrated into GitHub from the Merge box to the Checks tab, from the UI to the API. 2. Trigger a job on any GitHub event to automate any workflow in your team. 3. Community is at the heart of GitHub. Anything you build with GitHub Actions is shareable, because it is just code in a repo. You can make it public, fork it, edit it, and make it yours.com and guess via GitHub Connect. 4. And finally, it has to work on any platform, any language, any cloud. Because Actions is built in, there is no need to manually configure or set up CI and CD, to set up webhooks, to buy your own VMs, patch them and keep them up to date, monitor it, or do cost management, or shut down idle VMs. You just drop a workflow file in your repo, and you are up and running. Key functionalities of GitHub Actions include: run an action in a container or in a virtual machine with hosted runners for Linux, macOS, and Windows. Free on public repos on github.com, so you can run deployments and builds without worrying about setting up hardware. Self-hosted runners are an option for those who do want or need to set up their own hardware. Actions also supports matrix builds, so you can run parallel jobs across OS versions, runtime versions, or any variable you want to use to multiply your workflows. Example, if you wanted to deploy 3 different versions of Node. Actions gives you real-time feedback with streaming logs that are searchable and deep linkable, so you can share a link to a specific line of a log with a friend to get help debugging a build. To help integrate with third-party services or deployment targets, every repo on GitHub has a built-in secret store, and Actions will substitute secrets for your tokens, encrypted tokens or private keys. And finally, because it's GitHub, Actions are easy to write and easy to share. Built on the YAML syntax. This is core to how software development works today. Automate workflows. Deploy to any cloud. Millions of open source libraries. Interact with the any public APIs. Deploy to any cloud, create tickets in Jira, publish a package to NPM, and more. Use the millions of open source libraries available on GitHub to create your own actions. Write actions in JavaScript or create a container action. Both can interact with the full GitHub API and any other public API. Actions are used to automate any workflow. It could be workflows for onboarding teams, creating new repos and setting branch protections, creating releases, etc. Teams have custom workflows that enable them to bring standard methodology and practices to software development. Usually this involves integrating with other tools such as Jira or a package manager. A lot of customers use Jira. GitHub Actions connects all of your tools to automate every step of your development workflow. Easily deploy to any cloud, create tickets in Jira, or publish a package to NPM. Want to venture off the beaten path? Use the millions of open source libraries available on GitHub to create your own actions. Write them in JavaScript or create a container action. Both can interact with the full GitHub API and any other public API. The most common workflow is continuous integration and continuous delivery, but administrative tasks such as labeling can also be automated. Workflow possibilities. It goes far beyond just sift and check-in. Complete workflows from welcoming and maintaining issues to everything else. You can have a central repo with reusable actions and workflows so you do not have to start over every time. Components of an action. GitHub Actions is a new feature that allows you to customize your workflow on GitHub. Originally released in beta in 2018, the latest version includes powerful continuous integration and continuous delivery primitives, familiar YAML syntax, and the ability to run as a script or in a container. That is, I can automate, customize, and run my software development workflows directly in a repository with GitHub Actions. We can discover, create, and share actions to perform any job I want, including continuous integration and continuous delivery, and combine actions into a fully customized workflow. GitHub Actions are a way of automating your workflows. They are triggered on any event on GitHub. There are three main parts that constitute GitHub Actions: events, workflows, actions. Webhook events. A few examples are events in GitHub that could trigger a workflow are: opening an issue, creating a branch, creating a new pull request, adding a new member to an organization, cron schedule. A webhook is fired off when one of these events takes place and a workflow is triggered. Schedule. Some teams use weekly issues for team updates, meeting notes, or status check-ins. Cron jobs can open these issues from templates automatically and check to close them automatically if they are still open, so that when people wake up to their notifications on Monday morning, they see a notification and an already opened issue with the context they need to get started. This can be expanded with other automation to really fit the needs, like including aggregated data about how many issues are open in the backlog, or other project tracking mechanisms. Repository dispatch. The repository dispatch event can be triggered by external systems. You can make an API call where you pass anything you would like into a body parameter. It could be an object, it could just be a plain text string. That event will come through, and you can actually listen on repository dispatch events and then parse out the information within that dispatch that you sent. For example, if you are running something like Jenkins or self-hosted runners, you may have a web interface that will allow people to fire off their builds automatically. You can set it up so a click of a button sends a payload to GitHub, which creates this dispatch event, which will fire off the action. Workflows. Workflows are what the end user consumes. These are your pipeline, comparable to a Jenkins or a Travis file. A workflow is a collection of steps and jobs that are run. Workflows let you codify useful, customized processes. Workflows can solve several problems for various use cases. They can be used to solve issues that are organizational, such as creating a mechanism to welcome new contributors to a repository, or opening a new onboarding issue or project board automatically. Legal, to ensuring license and policy uniformity, like watching for branch protection, and if branch protection is removed, an action could be triggered to renable it right away. Application related, use them to test across multiple operating systems. Our focus today will be on continuous integration and continuous delivery, but these other use cases are extremely valuable and can go a long way in operationalizing and automating processes across your organization. Workflows belong in YAML files in a special directory in your repository, .github workflows. Workflows. Events, already discussed. Actions, we will talk about this in more detail soon. Existing actions that are pre-written and modular. Scripts, when an action is too heavy, scripting is an option. Workflows allow you to code useful processes to your liking. For example, welcoming new collaborators to your project, fixing outdated issues, ensuring license uniformity, or performing continuous testing and integration and delivery. Workflows are YAML files that allow you to initiate a series of actions on one or more jobs when certain events occur. They belong to a special directory in the repository that you want the workflow to run in, .github/workflows. Workflow files use YAML syntax, and must have either a .yml or .yarml file extension. YAML is a data serialization language designed to be directly writable and readable by humans. It's a strict superset of JSON, with the addition of syntactically significant newlines and indentation, like Python. Unlike Python, however, YAML does not allow literal tab characters for indentation. Let us see a little. Name. The name of your workflow. GitHub displays the names of your workflows on your repository's Actions page. If you omit name, GitHub sets it to the workflow file path relative to the root of the repository. On. The name of the GitHub event that triggers the workflow. You can provide a single event string, array of events, array of event types, or an event configuration map that schedules a workflow or restricts the execution of a workflow to specific files, tags, or branch changes. Jobs. A workflow run is made up of one or more jobs. Jobs run in parallel by default. To run jobs sequentially, you can define dependencies on other jobs using the jobs.job_I.needs keyword. Each job runs in a runner environment specified by runs on. You can run an unlimited number of jobs as long as you are within the workflow usage limits. If you need to find the unique identifier of a job running in a workflow run, you can use the GitHub API. The type of machine to run the job on. The machine can be either a GitHub hosted runner or a self-hosted runner. You can provide runs on as a single string or as an array of strings. GitHub hosted runners. If you use a GitHub hosted runner, each job runs in a fresh instance of a virtual environment specified by runs on. Available GitHub hosted runner types are Windows Server 2022, Windows Server 2019, Ubuntu 20.04, Ubuntu 18.04, macOS Big Sur 11, macOS Catalina 10.15. Self-hosted runners. To specify a self-hosted runner for your job, configure runs on in your workflow file with self-hosted runner labels. All self-hosted runners have the self-hosted label. Using only this label will select any self-hosted runner. To select runners that meet certain criteria, such as operating system or architecture, we recommend providing an array of labels that begins with self-hosted. This must be listed first and then includes additional labels as needed. When you specify an array of labels, jobs will be queued on runners that have all the labels that you specify. Although the self-hosted label is not required, we strongly recommend specifying it when using self-hosted runners to ensure that your job does not unintentionally specify any current or future GitHub hosted runners. A job contains a sequence of tasks called steps. Steps can run commands, run setup tasks, or run an action in your repository, a public repository, or an action published in a Docker registry. Not all steps run actions, but all actions run as a step. Each step runs in its own process in the runner environment and has access to the workspace and file system. Because steps run in their own process, changes to environment variables are not preserved between steps. GitHub provides built-in steps to set up and complete a job. You can run an unlimited number of steps as long as you are within the workflow usage limits. Select an action to run as part of a step in your job. An action is a reusable unit of code. You can use an action defined in the same repository as the workflow, a public repository, or in a published Docker container image. I strongly recommend that you include the version of the action you are using by specifying a git ref, SHA, or Docker tag number. If you do not specify a version, it could break your workflows or cause unexpected behavior when the action owner publishes an update. Actions are either JavaScript files or Docker containers. If the action you are using is a Docker container, you must run the job in a Linux environment. Runs command line programs using the operating system's shell. If you do not provide a name, the step name will default to the text specified in the run command. As an introduction, I think it is fine for the time being. Workflows can have ability to specify environment, can also have conditionals, secret store, encrypted. Secrets are encrypted environment variables that you create in an organization, repository, or repository environment. The secrets that you create are available to use in GitHub Actions workflows. GitHub uses a libsodium sealed box to help ensure that secrets are encrypted before they reach GitHub and remain encrypted until you use them in a workflow. For secrets stored at the organization level, you can use access policies to control which repositories can use organization secrets. Organization level secrets let you share secrets between multiple repositories, which reduces the need for creating duplicate secrets. Updating an organization secret in one location also ensures that the change takes effect in all repository workflows that use that secret. For secrets stored at the environment level, you can enable required reviewers to control access to the secrets. A workflow job cannot access environment secrets until approval is granted by required approvers. To take into account, if your GitHub Actions workflows need to access resources from a cloud provider that supports OpenID Connect, you can configure your workflows to authenticate directly to the cloud provider. This will let you stop storing these credentials as long-lived secrets and provide other security benefits. The following rules apply to secret names. Secret names can only contain alphanumeric characters A to Z, 0 to 9 or underscores. Spaces are not allowed. Secret names must not start with the GitHub prefix. Secret names must not start with a number. Secret names are not case sensitive. Secret names must be unique at the level they are created at. For example, a secret created at the environment level must have a unique name in that environment. A secret created at the repository level must have a unique name in that repository, and a secret created at the organization level must have a unique name at that level. If a secret with the same name exists at multiple levels, the secret at the lower level takes precedence. For example, if an organization level secret has the same name as a repository level secret, then the repository level secret takes precedence. Similarly, if an organization, repository, and environment all have a secret with the same name, the environment level secret takes precedence. To help ensure that GitHub redacts your secret in logs, avoid using structured data as the values of secrets. For example, avoid creating secrets that contain JSON or encoded GIT blobs. To make a secret available to an action, you must set the secret as an input or environment variable in the workflow file. Review the action's README file to learn about which inputs and environment variables the action expects. You can use and read encrypted secrets in a workflow file if you have access to edit the file. GitHub automatically redacts secrets printed to the log, but you should avoid printing secrets to the log intentionally. Organization and repository secrets are read when a workflow run is queued, and environment secrets are read when a job referencing the environment starts. You can also manage secrets using the REST API. When generating credentials, we recommend that you grant the minimum permissions possible. For example, instead of using personal credentials, use deploy keys or a service account. Consider granting read-only permissions if that is all that is needed, and limit access as much as possible. When generating a personal access token, PAT, select the fewest scopes necessary. Actions are reusable units of code made available to your workflows. The steps or jobs within a workflow are called actions. Actions are where the actual automation executes. So, we can say that workflows use actions. Referencing actions. GitHub runs them in a Node.js runtime or in Docker containers and are referenced from workflows as uses, owner/repo at ref. Official list, GitHub/actions. Authoring actions. Components to actions, when authoring. Action.yml, similar to a package.json file, defines inputs, outputs, environment. Index.js, main file for action entry point, includes code for action. We will discuss scripting vs containers shortly. Administrative features. Setting actions policies on the enterprise, organization, or repository level. Example. Just enable verified actions, or restrict to only using local actions. Storing shared actions. Yes, actions can live in repositories with other code. But why? They are not particularly usable in that case. But if you really want to do it, use something like .github/actions/my_action_ with _other_ tough. Marketplace. We will talk more about this shortly. Now let us look at action types and marketplace. There are two kinds of actions. A JavaScript action Node 12, a container action. The screen shows a chart with the important points to remember. Automate workflows. Deploy to any cloud. Millions of open source libraries. Interact with the any public APIs. Deploy to any cloud, create tickets in Jira, publish a package to NPM, and more. Use the millions of open source libraries available on GitHub to create your own actions. Write actions in JavaScript or create a container action. Both can interact with the full GitHub API and any other public API. Actions are used to automate any workflow. It could be workflows for onboarding teams, creating new repos and setting branch protections, creating releases, etc. Teams have custom workflows that enable them to bring standard methodology and practices to software development. Usually this involves integrating with other tools such as Jira or a package manager. A lot of customers use Jira. GitHub Actions connects all of your tools to automate every step of your development workflow. Easily deploy to any cloud, create tickets in Jira, or publish a package to NPM. Want to venture off the beaten path? Use the millions of open source libraries available on GitHub to create your own actions. Write them in JavaScript or create a container action. Both can interact with the full GitHub API and any other public API. The most common workflow is continuous integration and continuous delivery, but administrative tasks such as labeling can also be automated. Workflow possibilities. It goes far beyond just continuous integration and continuous delivery and check-in. Complete workflows from welcoming and maintaining issues to everything else. You can have a central repo with reusable actions and workflows so you do not have to start over every time. JavaScript may use the GitHub Actions toolkit for command line argument parsing, passing parameters, interacting with the GitHub API. For anything that compiles to JavaScript, you can run it as a JavaScript action. It will just run natively on the VM, whether it is Linux, Mac, or Windows. Because of that, you also get a little bit faster speed execution because the system runs the environments already preloaded with all the software that you need. JavaScript actions are faster, runtime is more versatile, and offer a better user experience. Container actions, if needs to compile, can be run in a container. Docker, similar to Beater 1 actions, but with updated syntax and argument passing. Or point to existing actions published to Docker Hub. If you wanted to write an action in a language such as Go, C# or something that does not compile back to JavaScript, that is where you need to put the action into a container. The containers only run on Linux at this time. The GitHub Marketplace is a central hub from which you can download actions that have been certified for many categories. A lot of actions do similar things, but for customers it might be relevant whether an action is maintained by an individual contributor vs official actions example from Atlassian. This can be controlled in the enterprise/org/repo settings. As an administrator, there are options for what actions you will allow to run. By default, GitHub Actions is enabled on all repositories and organizations. You can choose to disable GitHub Actions or limit them to local actions only, which means that people can only use actions that exist in your repository. You can enable GitHub Actions for your repository. When you enable GitHub Actions, workflows are able to run actions located within your repository and any other public repository. You can disable GitHub Actions for your repository altogether. When you disable GitHub Actions, no workflows run in your repository. Alternatively, you can enable GitHub Actions in your repository but limit the actions a workflow can run. When you enable local actions only, workflows can only run actions located in your repository, organization, or enterprise. You can disable all workflows for a repository or set a policy that configures which actions can be used in a repository. If you choose Allow Select Actions, local actions are allowed, and there are additional options for allowing other specific actions. When you allow local actions only, the policy blocks all access to actions authored by GitHub. For example, the actions/checkout action would not be accessible. You might not be able to manage these settings if your organization has an overriding policy or is managed by an enterprise that has overriding policy. Let us briefly look at some examples. Close outdated issues and PR. It warns and then closes problems and PRs that have not been active for a specific period of time. The settings should be in the default branch and the default values will be: add an obsolete tag on issues and pull requests after 60 days of inactivity and comment on them. Close obsolete issues and pull requests after 7 days of inactivity. If an update/comment on outdated issues or pull requests occurs, the deprecated tag will be removed and the timer will restart. Monolithic action example. The screen shows a sample workflow file in which the user attempts to build and release some code. After the release is finished, they want to tweet out about it and notify their community that a new version of the product has been released. Here is how the monolithic action is structured. A first step of checking out code. Next, there is a step called build and test that completely builds the project and then runs testing on it. The next step releases the project. We see a lot going on in one step. A lot of things happening and numerous inputs and information. Now let's compare the way this action is structured to a chainable action. Chainable action example. Notice on lines 1 and 2 of this code example how the action is structured by linking to another piece of code. Instead of having the inputs directly in the action, we import from another source. This provides flexibility. The same sort of structure happens in the following steps. Create draft release. Generate release notes. Edit release and add notes. The downside of the monolithic action is that it is difficult to locate points of failure when the action does not run correctly. There are always logs to look into. Starter workflows. Pre-configured for specific languages and frameworks. GitHub analyzes your code and suggests the workflows based on your language and framework. You can also choose from categories. For GIS 2.22.x, a number of actions come pre-packaged with the release. Access to .com actions via GitHub Connect. The documentation for using Starter Workflow is provided. Use Starter Workflows to get started quickly. You can use from a set of pre-configured workflows to create a CI workflow or an automation workflow. Examples of other Starter workflows: JFrog Artifactory, Terraform, OpenShift CLI, iOS, AWS, Azure deployments. If you do not have existing actions in your repo, then you will be presented with a set of starter workflows when clicking the Actions tab. The list of suggestions is based on the code analysis of your repo. For Enterprise Server 2.22 and above, a number of actions come pre-packaged together with the release. Let us see the options of troubleshooting and best practices. There are tools available to help troubleshoot while configuring or writing actions. Have you tried writing your workflows on GitHub and not VS Code? There is a workflow editor that provides GitHub action-specific autocomplete and linting, which helps validate the workflow file YAML before you commit. Things to keep in mind. Events kick off the workflow. Jobs run each in their own VM. In parallel, unless the workflow says otherwise. Job specifies the VM Linux/Windows/Mac OS. Steps run in the same VM. Share file system. Logs are searchable, linked to individual lines. Artifacts can be saved. Can run jobs in parallel or in sequence using the needs option. Within jobs you have individual steps that run in sequence. You can chain workflows using the workflow_run event. What are some best practices when writing actions? Write actions in a way that they can be used with others. Version your action. Example 1.0.0. Include a version 1 tag that points to the first version. Use a latest tag pointing to the latest version. There are actions that can watch your action to increment version numbers automatically if you would like to use those. Good documentation. The better you document your action, the better of an experience users will have implementing it. This applies both to open source and in-house. Within the company even, you want people to know who to contact with questions. A well-written README will serve this purpose. Create unit tests. It is even possible to have actions to run these tests. Maintain your metadata. The metadata in your action.yml needs to be kept up to date. It will provide information such as entry point of your action, the author, a description. I hope this little introduction to GitHub Actions has been useful to you, and remember that GitHub Actions is a continuous integration and continuous delivery platform that will allow you to automate your build pipeline, test, and deploy. Thank you very much and see you next time.